Alright, so today we are going to go ahead and jump into operations on rational expressions. Okay, so this is going to be section 6.2 of our textbook. I'm going to go through the notes just like we normally do, and then I'll jump over to the whiteboard and work on some problems. One thing I want to point out, this content can be a little tricky to kind of wrap your head around, so I'm going to try to take my time going through it, but I do want you to be aware that a lot of times this is like the content especially that can really trip people up. So first thing that we're going to talk about is multiplying and dividing rational expressions. The second section, you can think of this as being split into two parts. The multiplication and division, and then the adding and subtracting is going to be the second part. Okay? The adding and subtracting, surprisingly, is more challenging than the multiplying and dividing. However, let's just go a piece at a time, and hopefully this won't be too much of a problem here. All right, let's go ahead. The product of two rational expressions is the product of the numerators and the product of the denominators. Okay, basically what this is saying is if you've got one thing multiplying another thing, multiply across. That's it. Literally, it's pretty much all it is. So x minus 3 over x plus 4 times x minus 5 over x minus 5. We multiply across, so x minus 3 times x minus 5, which is all in the numerator. We multiply across, all in the denominator. And we get this guy, x squared minus 8x plus 15 over x squared plus 9x plus 20. In this case, so I do make a quick note, there's occasionally places or situations where actually you'll have things cancel out right at this step. That wasn't the case here because nothing, you can see it's matching up. There's nothing matching, so I can't cross anything off. But I do want you to go ahead and take a look at an example on page 331. You all have access to the textbook, so please go and take a look at that example. It should show you pretty much what happens in that case. When we get to dividing rational expressions, we need to use the reciprocal. The reciprocal is where you flip one of your fractions upside down. So, when we're dividing rational expressions, say for example this problem, okay, you can see it's kind of bananas, all the stuff going on. I've got this divided by this. As soon as you see a division, the very, very, very first thing that you should do is change it to multiplication and then just flip the numerator and denominator of the thing you're dividing. Or the thing that you're divided by, I should say. So what we do is we turn this guy right here into this. So notice all we did is just flipped that second piece and we changed the sign in the middle to multiplication. Here is what we do with the factoring. Okay, I went ahead and factored this for you kind of on my own. Again, if you get stuck at this part, take some time, work through it, work through the problems. Don't just assume, oh, I can do it. You know, if you genuinely don't understand how I got from here all the way down to here, then you need to take your time, work through the problem, and then hopefully it will match up when you do it. Okay? So we get a lot of common pieces. Okay? These are all multiplying by each other. We can multiply across like we did in the last, like right up above here. But since we're multiplying, there's things that are just going to cancel out. So I have a 2x minus 3 down below, a 2x minus 3 down below. I have a 4x squared and a 4x squared. I have a 2x plus 3y and a 2x plus 3y here. So you can see the things that I canceled out with the respective colors. So I've got the reds matching the blues and the black lines that are all matching up. And then all we're doing at the very end is just seeing what is remaining. So 2x minus 3 is left with a 4y squared, which is left. So this is pretty much how you do multiplication and division with rational expressions. When we get to adding and subtracting, it's going to be a little bit more challenging, okay? Because the reason, just like we have with numbers, when we're adding and subtracting fractions that are purely just numerical, you have to find common denominators. Well, the same thing applies in this case. So I went through a pretty extensive example here, kind of explaining it all, but I'm actually going to do something similar in a problem. I don't want to go through this step by step. I'm leaving this here for you pretty much just so you can kind of read through it if you have questions on it. But let's go ahead and jump into some examples. Again, there's two parts in this, so it's going to be kind of intense. So I'm hoping we'll be able to get through this not only in a timely fashion, but hopefully in a way that is really easy to understand. That's always the goal. All right, let's do some multiplication. Question 16. Okay. X squared plus x minus 6 all over 12 plus x minus x squared. I'm going to show you a little trick here to fix that denominator because it's kind of annoying. We don't want that. X squared minus 4x plus 4. Okay, so you can see there's going to be a lot of factoring. However, this first piece is kind of annoying because it's backwards. So one thing you can do is you can negate, put a negative sign in front of this entire first piece. And the reason why this works is because if you multiply this by a minus 1 over a minus 1, the numerator will become negative, and then this thing will become basically what you want it to be. So essentially what we're going to have is a minus x squared plus x minus 6 all over x squared minus x minus 12. So I changed the signs of every single piece down in the denominator here. Okay. X squared plus x minus 20 all over x squared minus 4x plus 4. Okay. So let's go ahead and do a whole bunch of factoring. We're going to have a minus sign sitting out in front. X squared plus x minus 6. That's going to be a 3 and 2. And since one's negative here, this one of them is going to be negative, one's going to be positive. And since adding them creates a positive, the bigger one will be positive. So x plus 3, x minus 2. I gotta be careful, I might run out of room here. I think I'm going to. Well, we'll see. Alright, so then for 12 it's going to be 4 and 3. And since the adding them produces something negative, that means that the bigger one will be negative. So this is going to be x minus 4, x minus 3. Multiplied by 5 times 5 and 4 can produce a 1. Since this is positive, that means that the bigger one is positive. X plus 5, x minus 4. Ooh, barely fit. Okay. And then 2 and 2 are going to be the factor here. So this is going to be x minus 2, x minus 2. All right. So now we got tons of factors, and all we have to do is start crossing them off. So I've got a minus 2 there, minus 2 there, a minus, whoop, not a minus 3. Whoops, sorry. That stays. Minus 4 and a minus 4. And did I make a mistake? I think I made a mistake. Dun, 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 dun. Plus x. Plus 3 minus 2. Oh, this is supposed to be a plus. This is a plus 3. My bad. There we go. Now they cancel. Awesome. That's exactly what we wanted. Okay, so now we're left with a minus, and then that's going to be an x plus 5, minus x plus 5, all over what's left, and x minus 2. Okay, so there's our final answer. All right, so that's the first question. Let's go ahead and keep going. I was not exaggerating when I said there's a lot of factoring, because that's pretty much what most of this is made up of. 21, we're going to do 6x squared, y to the 4th, all over 35a squared, b to the 5th, divided by, let's see, 12x to the 3, y to the 3, all over 7a to the 4th, b to the 5th. Okay. So the first thing, immediately when you see a division sign, you think, okay, this thing has to be a reciprocal, and we change it to multiplication. So let's go ahead and do that. I'm going to write this out. Writing it out is the thing that actually takes the longest amount of time, which is kind of insane, but that's how it goes. Squared b to the 5th times 7a to the 4th, b to the 5th, all over 12x to the 3rd, y to the 3rd. Okay. Now what? Now what we are going to do is, since we're multiplying, let's just write out what the multiplication is among everything, okay? And we'll do it alphabetically. So 6 times 7 times a to the 4th times b to the 5th times x squared times y to the 4th, all divided by 35 times 12 times a squared times b to the 5th times x to the 3rd times y to the 3rd. Okay, wow, that was a lot. So one thing you can do is you can actually multiply all these out and then divide if you want to use a device. There's actually an easier way to do it. So since these are all broken up into individual, these are kind of factors, they're just multiplying by each other. 6 actually goes into 12 twice, okay? 7 goes into 35, 5 times? So actually what you can do is you can change it. 6 goes into 12 twice. So in the denominator, you're going to get 7. So that's going to be a 5 times a 2. And 7 times, those are going to go to 1 because we're dividing. Okay? 7 into 35 and 6 into 12. So you can think of it as 1/2 and 1/5. Okay? A to the 4th divided by a squared is going to be a squared. B to the 5th over b to the 5th. These are going to cancel. X to the 2 over x to the 3rd. Here, let me... this is going to be x to the 1st, right? Because the bigger one is remaining in the denominator. And then we've got a y in the numerator. So the final answer in this case is going to be a squared times y all over 10x. And there it is. That's our final answer. Okay, so we're just canceling things out. We're multiplying things across. Yeah, I mean that's pretty much what a majority of this is. All right, let's go ahead and jump to question number 55. So we just did a couple multiplication. We did a division one, which is the inverse of multiplication. 55, this is where we're going to start doing some adding and subtracting. The first one that I want to show you is really the easy ones. Oops. And I say easy because all it takes is a recognition of what the denominator is. If you can match it up, then you're in good shape. Minus 3x plus 2. Okay, so in this problem, the nice thing about it is the both denominators are the same. And so we don't actually have to find common denominators here. They're all the same. It's going to work perfect. So we literally, I mean, again, it's as simple as just x minus 2. So we're subtracting 2 from x. And then since we have common denominators, we can do that. That's literally it. This is factorable. So let's do the denominator, x minus 2 all over. This is going to be 2 and 1, and they're both going to be negative. So x minus 2 times x minus 1, and my minus 2 and my minus 2, x minus 2 and x minus 2 cancel. So I'm left with a 1 over x minus 1. And this is my solution. Okay, so that's fully simplified right there. All right, let's go ahead and move on to question 64. I'm going to do 2 more problems. Question 64. 5 over x minus 4 plus 2 over x plus 6. So to find common denominators here, here's what we're going to do. We're going to multiply each component by the other denominator. Okay? Our common denominators, here's the reason why. Common denominators, common denom. This is going to be x minus 4, x plus 6, okay? And so in order to get this, we need to multiply by the missing component. So this is the same thing. I'm just, again, bear with me as I write this out. X plus 6 over x plus 6 times 5 over x minus 4, okay? Plus 2 over x plus 6 times the missing piece, x minus 4 all over x minus 4. Okay. Now remember what we did earlier. We multiplied across. So this is adding. That's kind of where we can't do anything. So think of this left side as multiplication, this right side as multiplication, and then we're just going to merge those things together. So let's go ahead and do that. Multiply across, so 5 times x plus 6 all over x plus 6, x minus 4, plus 2 times x minus 4 all over x plus 6, x minus 4. Now, again, the reason why we did this is because the whole goal was down here to find common denominators. Now that they are exactly the same, as you can see, we can merge them all together into a single fraction. I'm going to just kind of on the side multiply this out. This is 5x plus 30. This is going to be 2x minus 8. Okay, so I've got 5x plus 30 plus 2x minus 8 all over x plus 6, x minus 4. It's a weird 4. All right, and then one more time, we can merge these together. This is going to be 7x. 30 minus 8 is going to be 22. And this right here is going to be x plus 6, x minus 4. And nothing cancels out or can be simplified any further. So here is our final answer. Right. So that's 64. Let me do 68. Okay. Again, it's a very similar process. There's just one thing that's a little different. Actually, I might do a different one. I don't even think I have this. I think I did 68 in the notes. So I don't know if I want to do that one. Let me see here. That one's adding. I want a negative sign. All right, let's do, yeah, we're going to do 68, okay? This one I'm probably going to need a lot of space, so I hope I have enough. X plus 1, x minus 5, minus x plus 4, x plus 2. All right? So the common denominators are just going to be these individual denominators multiplied together. And remember, what we do to one side, we have to do to the other side. So, or in a fraction, what we do to the bottom, we have to do to the top. It's the same idea. So the missing piece here is going to be x plus 2. So x plus 2 all over x plus 2 times x plus 1 all over x minus 5 minus, and I'm going to rewrite it out, the missing piece is going to be x minus 5. Okay? Now, this minus sign is going to be a little tricky, and I need you to be very cognizant and pay attention to it. Okay? Because otherwise it's going to come back and turn into like a flesh-eating vampire, and you're not going to like it because it's just going to give you nightmares, and you're going to be really scared, and you're not going to know what to do, and it's not going to work out, and problems are going to persist, and you're going to be like, why am I doing math? So pay attention to the minus sign, okay? I'm being a little silly, obviously, but yeah, pay attention to that minus sign. Okay, so here we go. Let's go ahead and multiply these things out. X plus 2, x plus 1, x plus 2, x minus 5. Okay. Normally we would cancel these, but obviously we're not doing it because we're trying to combine them together. Minus x plus 4, x minus 5, x plus 2, x minus 5. Okay. Now, let's multiply these out in the numerator. We do not need to multiply the denominator out, okay? You don't need to do that. I'm just going to leave it as is. Sometimes you get lucky, and in the end, things will cancel, so always leave it like that. All right, so we're going to get x squared plus 2x. Whoa, did I write this down wrong? I totally did. This is a minus. Okay, sorry. Minus. Okay. That shouldn't change anything. It should all be the same. And of course, you probably can't see that because it's over top. There we go. X squared plus 2x minus x. This is going to be minus 2 all over. This is going to be, again, x plus 2, x minus 5, minus, what's up top? X squared plus 4x minus 5x minus 20. Again, I'm doing FOIL on all of these. X plus 2, x minus 5. Okay? So now, I'm probably going to need some space, so let me come down here. Now we can combine them because they have common denominators. So x squared, let's just simplify this. This is going to be a plus x minus 2 minus every single one of these pieces, okay? This is where the nightmares that I was talking about earlier can happen. You need to be very, very, very careful here. X squared plus 4x minus 5x is a minus x minus 20. Okay. All over x plus 2, x minus 5. Okay, now take a look at what happens. This minus sign is distributive. In other words, it goes to every single piece that you see here. So it goes to the x squared, the minus x, the minus 20. So x squared plus x minus 2 minus x squared plus x plus 20 all over x plus 2, x, that's an x. I'm writing a little too fast here. X minus 5. Okay, one more step and we should be done. X squared minus x squared, that goes away. I've got an x plus an x, which is a 2x, a minus 2, and a plus 20, which is a plus 18, all over x plus 2, x minus 5. And actually, you can factor this one more time. If you can see down here, I hope you can. 2 can come out of both of these, and I'm left with an x plus 9 all over x plus 2, x minus 5. Okay? That is my final answer right here. Again, it took a lot of getting there, but if you go through the process, take your time, you walk through it, you should not really have too many problems. Okay? The tricky part, again, is the very first part. You just have to remember to multiply by whatever piece you need. So it's pretty much the opposite denominator in, I would say, in most cases. Okay? So we're going to multiply by the opposite denominator times x minus 5. Multiply over here the opposite denominator times x plus 2. Okay. All right, well, that's pretty much it for the adding and subtracting. If anyone has any questions, don't hesitate to let me know. And I hope you have a fantastic day.